together, let's say, after 2,000 or 3,000 cycles.
So you have described a much slower loading frequency than 0.05 Hz.
Yeah, that would be the best. Yeah, that's true.
Thank you.
Thank you.
Okay, thank you. Congratulations, sir. And let's end our session. Again, this is Orlene J. De La Cruz from the Polytechnic University of the Philippines. Thank you.
Thank you, Professor Orlene De La Cruz, for your chair. Now this session will be chaired by Dr. Hamidu Hamadan Tambora.
Present is I think this one 13154. Okay.
Good morning, everyone. My name is Erika Migayo. I am a graduate student at Keio University in Tokyo. The title of my presentation today is Fundamental Study of the Effect of Particle Shape and Relative Density of Sound on the angular report test results. To put it simply, I did the angular report test focusing on the shape and relative density dr of the particles. My presentation today is divided into 3 parts: background, methods, and results and discussion. First, let me explain the background. This slide explains the angle of reports. Matsukura and Onda define the angle of reports at the angle of the slope of a cone mountain created when sand is dropped from above. They also define the angle of report with 2 parameters: critical angle of report, alpha c, and report angle after avalanching, alpha r. The angle of report has these features. There are 3 main testing methods: emission method, injection method, and inclination method. Alpha C and alpha R that can be measured are different for each of them. This slide shows relationship between internal friction angle, phi, and angle of report. The angle of report is often referred to as phi for convenience. Phi is a crucial parameter in design considerations and resistance value of the soil to shear forces, which is known to be highly influenced by the particle shape. However, obtaining accurate phi is difficult, and the relationship between these angles remains poorly understood and is established by experience. There are 2 main methods for determining phi for sandy soils: laboratory soil testing and estimation equations based on end value, of the standard penetration test, SPT. However, both methods are disadvantageous when used in practice. We have focused on estimation equation using n value, so we hope to develop a highly accurate estimation method. This soil collected from the SPT is considered disturbed sample and cannot be used for laboratory soil testing. Therefore, our study aims to contribute to these issues by the improvement the accuracy of the fire estimation equation by conducting simple physical and mechanical tests on this sample. We then used the angle of repose test as this method. In this presentation, we performed emission method using a mode and color modified with reference to test method for minimum and maximum densities of sand. The aim of this presentation is to examine what influences the value of the angle of repose. Next, I will talk about the methods. I explain emission method that can measure alpha R. Following this, the instrument was modified to measure alpha R. We used the top surface of the mold, which was sharply angled, and the color with a height of 40 millimeters was placed on top. The right video shows a sample being placed at minimum densities. Here I am giving a blow to the mode and color for intermediate and maximum densities. Blow times are varied to create an intermediate density. After that, I lift the color upward to create a slope. The created slope was assumed to be a perfect conical shape. By measuring the apex height of the created slope, the alpha R was defined from the bottom width, dB, and height, h. These are the shapes of sand particles in our four samples: Toyota sand, mountain sand, river sand, and glass beads. River sand is more angular, glass beads are spherical. This slide shows the particle size distribution curves and the densities. Glass beads are a mixture of 0.5 and 1 millimeter in diameter at a weight ratio of 3 to 1. Finally, here are results and discussion. This graph shows the results for alpha R of all samples. Green is glass beads, blue is Toyota sand, orange is mountain sand, and purple is river sand. All samples and density conditions variations were smaller and alpha R increased with more DR. Therefore, we believe that our improved emission method is useful. The largest gradient of alpha R with respect to DR is river sand, followed in order by mountain sand, Toyota sand, and glass beads. Also, regardless of sand density, the alpha R values are of the same sample order. This gradient on DR is different for each sample. This suggests that this gradient is affected by the physical properties such as particle shape. This is because the gradient of river sand with the most angular particle is the greatest, and one of spherical glass beads is the lowest. This suggests that gradient is affected by the soil particle. The angle of repose is found to be of the same property as phi in terms of being influenced by the particle shape. Therefore, the gradient may easily evaluate the angularity of the soil particles and may be useful for estimating phi. Here is the conclusion. We will experiment with different particle shapes with the same particle size distribution in our emission method. Here are the references. Thank you for listening.
Thank you very much, Kamekawa-san, for your presentation. Very nice. Does anybody have a question for her? Okay.
Thank you for your presentation. And can you show the page displaying the figure of this page? I'm wondering why you have this data points of relative density smaller than 0% and larger than 100%.
Okay, thank you. I use the average, mean, and max densities for the emission method because there are variations.
So you are not using the minimum void ratio and maximum void ratio of difference as the reference data to calculate the relative density.
Sorry.
So you didn't use the minimum void ratio or the maximum void ratio to calculate the relative density for each sample. Otherwise, you should.
I think she used Japanese standard method to determine the relative density. どうやって DR の得た E minimum と E maximum. E minimum and E maximum. Did you use those? Anyway, maybe we are running out of time there. Please explain to him later. Sorry. Okay. Next presenter. Presentation number 13161. I think it is Panta? Okay. Something like is this one? Yes, 161. He's not here. He's coming. Oh, thank you. Reset this.
Hello everybody. So my name is Hanbari Ramursa and I came from Mongolia. So now I'm studying in Hokkaido Kitami Institute of Technology. I'm a master's student. Today I would like to share my graduation thesis, the basic study on adaptation of sub-base course, reinforcement method using the geocell to cold regions. Okay, introduction. This is today's contents. Let's skip this. So, introduction. In the northern hemisphere, such as Mongolia, Canada, Russia, and the Hokkaido region of the Japan, where there is a lot of snow and cold areas, road damage occur due to the soil freezing. Now, additionally, in Mongolia, the thawing of the soil permafrost and refreezing of the thawed soil are causing increased damage to the roads. The photo shows the damage damage to the road in the northern district of Ulaanbaatar city. It's the capital of Mongolia. So in Japan, the method replaced the soil below the road embankment with the soil that's not sensitive to cold up to the maximum freezing depth. But in Mongolia, there is a maximum freezing depth is greater than in Japan, and average frozen depth is up to 4 meters some places, and the maximum is 10 meters. It's considered economically challenging to use the substitution method. For this reason, we tried to strengthen the road subbase by using geocell instead of the traditional soil replacement method. The method of strengthening the subbase using geocell increased the bearing capacity and suppress uneven settlement and disperse the pressure from above. In this study, we obtained the result by observing freezing and thawing and loading period of actual test road reinforced with the geocell. So, overview of the full-scale model experiment. We built a 24-meter long and 4-meter wide actual road for this experiment on the special site. This scheme shows the profile of the full-scale simulated road. The figure also shows the arrangement of the various measurement instruments, and experiment was conducted in the 3 cases. Case 1 is the known measures. Case 2 is a 1-layer geocell. Case 3 is a 2-layer, double 2-layer geocells. So following photos are full-scale simulated roads during construction. 2 layers of geocell material were backfilled and subgrade soil and compacted with the hand guide rollers. And sand with the high frost susceptibility was used for the subgrade soil in all 3 cases. And crushed stone C80 was used between cases as the subgrade soil to the separate to each cases, the gray one. So following figure shows the case 3 example configuration of the subbase course reinforcement method using geocell in this study. So we used the soil material with the high frost susceptibility as the subgrade soil. The first figure shows the grain size accumulation curve of the soil sample. This soil sample is classified as a sand. And the following figure shows the compaction curve of the soil sample obtained the Japanese standard. So we performed the following test in the States during the construction of the roads, where they placed under the road, which was very helpful, obtained accurate results, and temperature measurement rods were buried to measure the frozen depth. The sensor were installed 0.3 meter intervals to the 1.5 meter depth. And the amount of the frost here in the winter time, amount of the subsidence in springtime were observed by labeling road surface. Also, we did running test dump truck, running test of the dump truck, which is a 10-ton. We used the 10-ton dump truck. After freezing and thawing, a dump truck made 30 round trips, and the soil pressure guides was buried directly under the subbase course. also we used drone survey in addition to the lead in charge of road surface was measured by three-dimensional by the drone survey. So result and discussions and in all cases frozen depth reached 0.3 meter in early December 2022 and reached the surface course, and maximum frozen depth was reached between early and mid-February 2023, and frozen depth was deepest in the case 1 and shallowest in case 3. So this figure shows the result of the plate load test, comparing the test result in unfrozen state. It can be confirmed that the case 2 and case 3, which is sub-base course was reinforced with the jaw cell, had less subsidence than the case 1, which is no measure were taken. So when compared with the after freezing and thawing, it can be that the amount of subsidence case 2 and case 3 is almost the same in the unfrozen state. So time is limited. Let's move the. So first figure shows the change of the soil pressure during the running down track test. It can be confirmed. So it's
Sorry,
discussion.
thank you very much for your presentation. Very interesting. Does anybody have a question for him? Any question? No? For me, question for me. How can you explain what is the mechanism that the jaw cell can decrease frozen depth? Can you go back
Which slide?
back again? Yeah, this the left hand side. What is the mechanism that the jaw cell can reduce the depth of the frozen soil? Do you know? You know this mechanism? Because from this left figure, you have the depth is reduced when you have the jaw cell, right? Is it right? From this figure.
I don't understand what.
The left hand side figure,
Oh, okay.
the first black one is no jaw cell, right?
Yeah, no, just
The middle one is one layer.
one layer.
The second one, the third one is two jaw cells.
So layer.
So according to this, when you have jaw cell, depth of the frozen part is reduced.
No, it's almost the same.
Is it same?
Yeah.
Really? I don't think so. But okay. Just one recommendation also. This one is just one season, one winter.
Yeah.
What will be the effect of two years?
Yeah. Also, my supervisor, my professor wanted to repeat it in next year, and
Okay.
this time it's we just some failure of the compaction. We use the hand guide roller. It's not enough to compact with the subgrade subbase layer, and next year we will do it repeat.
Thank you very much.
Thank you.
Yeah. Let's go to the next presenter. ID number 163. Lesson of the implementation for presenter name. Asif Sananda. Is that right? Asif Sananda is not here.
Laboratory 13163, Asif Shananda.
let's move to the next. Maybe she's not here. ID 13164. Haram, yeah.
Good morning, everyone. I'm Haranjan from the University of Tsukuba. And today we'll be talking about the shape-dependent rheology of dry granite materials. It's a numerical study using the level set discrete element method, or LSBM. Firstly, let's introduce the background of this study. And we all know the granite materials can be commonly found in daily life. And they can behave either like the solid or fluid. And the fluid-like state is referred to as the granular flow. The granular flow can be frequently encountered in the geodisasters like the landslide and avalanches. So it's pretty important to predict and understand the flow behavior of granular flows in order to prevent the disasters. However, it's not that easy because of the discrete nature of the granular flows. Usually the granular flows are composed of discrete particles with distinct properties, making it very difficult to establish a continuum model to describe it. And thanks to the development of the numerical tool, like the discrete element method, DEM, which allows us to model the granular flows from the viewpoint, the discrete viewpoint. And in this study, we mainly discuss how to propose a continuum model for describing the granular flows. And recently, there was a very popular model called rheology model, which is used to describe the rheological behaviors of the granular flows. And in this model, the researcher introduced the rescale shear rate called inertia number to describe two key parameters, the shear stress and solid fraction, or the void ratio of the granular flows, which is proven to be valid for different geometries. But however, you might notice that in this inertia number, it only contains very limited information on particle properties. So what if we want to extend this flow to more complex granular flows? Usually we need to consider the effect of like the particle friction, the particle size distribution, and also the particle shape. And in this study, so to account for those effects, we need to make the corresponding corrections to the inertia number. We need to redefine the inertia number based on the effect we want to consider. And in this study, we may consider the effect of particle shape. And we aim to propose a shape-dependent inertia number to describe the properties, the behavior of granular flows. And the particle shape considered in this study is the superellipse. Here's the surface function of the superellipse. There are two shape parameters, the elongation, also known as the aspect ratio, and the bulkiness, representing the kind of the angularity of the particle shape. And then by considering the combination of these two shape parameters, we mainly studied three different shape groups. The first shape group is the ellipses. I think most of us are very familiar with it. And then we consider this particle shape with constant elongation but varying bulkiness, and what is referred to as superdisk. Finally, we also consider the very general superellipse with these two shape features at the same time. And then we propose to use very simple shape parameter to describe the shape features of all considered particle shapes, called sphericity. The sphericity is defined as the ratio of the radius of maximum inscribed circle and the ratio of the minimum circumscribed circle. And you can see the sphericity of all explored shapes covers from the range from 0.3 to 1. And to model the interactions between particles, we adopted the level set discrete element method, or LSDM. Well, the concept of LSDM is very simple. Basically, you need to compare. You find the contact between the particles by comparing the level set function of one slave particle to the discrete surface point of one mass particle. Then it allows us to obtain all the contact information required for the force computation, and then we can just deal with the gradient system like the usual DM. We can update the velocities and positions and all the quantities of the particles in the gradient system. And then using this method, we perform the symbol sharing test. Firstly, we prepare the samples using the isotropic compression, and then using the prepared samples, which we move the plates close to the top and bottom boundaries and move them relative to each other to share samples. And here I should videos give you this visual idea of the sample preparation. And then we get the final packings, the prepared samples, and you can see for the non-circular particles, usually they have more contacts than the circular system, since they can rotate to fill in the voids. And then using those samples, we further did the symbol sharing test. And at this stage, the particle friction was set to 0.5, similar to most natural ray materials. And all samples were shared up to a very large deformation. And here's the snapshots of the samples during the shearing. And you can see the forces were propagated in order to resist the shearing during the shearing. And you can observe very clear force and contact anisotropy due to the shearing. But this is not our main focus here. And then we calculated stress tensor using the force information and contact information. And then we calculate stress ratio based on the stress tensor, and we try to relate the inertia number to this shear stress. Of course, we want to propose a new inertia number, but still, firstly, we need to check the relation between the shear stress and the original inertia number. And you can see the relationship between the shear stress mu and the inertia number I, they are very simple. Basically, the shear stress from all explored samples increases with the increasing inertia number. And the difference between them is not only due to the difference in the start point, the quasi-state limit mu0. So you can see even we subject the shear stress, subject the quasi-state limit and the shear stress, still you will have large deviation from different samples, and the same thing happens to other shape groups. And then we propose to use the sphericity, firstly describe the quasi-state limit. And you can see there's an almost linear relation between them. And also, using this sphericity, we redefine the inertia number. And using this proposed inertia number, all the shear stress increment collapse onto one single curve, which can be fitted with by polar scaling. So to conclude, the shear stress of the explored gradient system can be predicted by the sphericity-based relative model, where the quasi-state limit can be linearly related to the sphericity, and the incremental it can be collapsed on one single curve using the proposed inertia number. So the sphericity is key of this model, and of course the physical mechanism behind this model is still requires further investigation. Thank you.
but maybe you will not have enough patience. Thank you very much for your presentation. 30 seconds. Does anyone have a question for him?
Is there anything about packaging index to consider?
Sorry?
Packaging index.
Package? You mean?
That is arranged how many number of grains?
No, we are not using any package. You mean you mean the simulation?
The arrangement of grains
You
will
mean,
vary depending on the shape.
sorry, I don't think I get it. But in this study, we use our in-house code to perform the EM simulations and consider different particle shapes. That's all. I'm not sure what kind of package you are mentioning.
Okay, let's move to the next presenter, please. I think. Thank you very much. 13167. Sapong, can you read this? Easy. Thank you. Okay.
Hello everyone, my name is Michelle, student from Konkan University, Thailand. Today I would like to present my research, the research about soil stabilization. The title is Stabilize Soil Using Recycled Asphalt Pavement for Substrate and Base. Okay. In Thailand, we are many roadways that still have repairing and reconstruction. For this process, we must to use so many material to use as embankment, space or base for road construction. In this case, I mentioned on base and space because in my country, Thailand, especially in my city, Konkan, there is a problem about material that used as subbase and base. Usually we use laterite soil as subbase and crush rock as base. But now it's not sufficient. The source of material hard to find. We must use from the source that too far from the site construction. So it is a problem of transportation and the cost is too expensive. If we use transport, if we transport the material from the outsource. Therefore, my paper would like to use the local material and improve or stabilize this material for represent the outsource. Okay, from July 2019, study using stabilizer laterite soil as pavement material. And from the standard of Thai highway, the minimum of unconfined compressive strength on the light traffic is 1,724 kPa. And we can see that if we use mixing between laterite soil and using cement 1%, and curing for 78 days. And confined compressive strength can be used as base at light and heavy high traffic. Next, from this graph, also 2022, I found that the unconfined from compressive strength is increasing with 5% of cement. The material RAP is recycled asphalt pavement. RAP we receive from repairing road construction by process milling of asphalt concrete pavement, and we collect at the Department of Highway Thailand in my state. The size of RAP materials must passing sheet number T divided by 4 inch to sheet number 200 inch, and the percentage of bitumen that coating on the aggregate have not over by 2.6% by weight. Soil aggregate. In this study, I tried to find soil aggregate near the main road for easy to transport in my city. The process of experiment is use soil mixing with recycled asphalt pavement and stabilized by cement, and we got the products. Concept of experiment. Mixing ratio of soil and recycled asphalt pavement we use for mixing and 5 samples per mixing, and use cement 5%. And we testing safe analysis, compaction test, and unconfined compressive strength test. What is the result of recycled asphalt pavement safe analysis? We have 360 is 7.4, D30 is 3.05, D10 is 1.2, and the coefficient of uniformity is 6.17, and coefficient of curvature is 1.05. This is the result of unconfined compressive strength in each mixing. We see that the trend of graph is almost same total for graph. The maximum strength is 1,100 approximately. From this graph, we found that all these material mixing can be used as substrate material, but cannot use for bed. In this graph, we can see that when mixing with recycled asphalt pavement, at the beginning the unconfined compressive strength is increasing and then it drops. So we can determine that the optimum point conclude that according to my study, we suggest that the appropriate mixing of recycled asphalt pavement should be 30 to 50% mixing of unconfined composite strength is 1,100 kPa and RAP approximately 42%. Okay, I tend to end of my present. Thank you.
Oh, thank you very much. Okay. Any question for him in the audience?
Sorry.
Okay.
Could you please, the question is it possible to... Is it possible if we clean the pavement before, because of the strength, I'm not sure the strength is decreased due to the content of bitumen or not. If you can, do you have any idea on that? To clean the bitumen out and to get the limestone, right? The pavement is in limestone.
I don't clean the material but I collect from the site, and we test percent bitumen, and we fix that not over than this.
Okay, I see. Thank you.
question? Or did you try to put this in practice? Your Did you try to put it in practice? Put your method.
Yeah.
Like practically road. Did you try?
Not practical, but only laboratory.
Only laboratory.
Yes.
Okay. So, what is your plan? Are you planning to do like full scale,
Yes, yeah.
full scale testing,
In
experiment?
in the future, I must try.
Okay. Thank you very much. Okay.
Thank you very much.
Thank you for that. Okay, let's move to the maybe last presenter for this session. Number 168.
Hello everyone, my name is Panwat Dadasai from Khon University in Thailand. Today I would like to talk my research name is Case Study of the Slope Stability of Bung Nongkot at Ban Pek Mueang District, Khon Kaen Province. Introduction. The flooding in Khon Kaen Province during the period from May to September 2022. Khon Kaen District plan decided to use Bung Nongkot as the reservoir from the flood before the rain season. The water in Bung Nongkot was drained out to catchment area. Therefore, the district is concerned about the drain out of water at Bung Nongkot would lead to a potential landslide or not. Site study at Bung Nongkot, Khon Kaen Province is Thailand. Literature review Kakaradi 2013 thus found safety factor depend on the depth and slope of the lake excavation, and 2. The size of width of the excavation pit does affect the stability of the slope. Ithakchulman and Viryaship Oil 2016. Thus far, internal friction angle of soil has more significant influence on safety factor than cohesion. Solvit Tansi and Ratamani Nasan 2021. Thus far, when water level rapidly to 75%, safety factor will be lowest and the soil movement was increased. Objective, we will determine the maximum factor safety of the slope stability on the lowest water level of Nongkot Swarm. The methodology of this study, we going to site investigation by doing soil boring and get the sample for the laboratory testing by standard penetration test. We use N to estimate the engineering property with this under shear strength and the friction angle. To the laboratory test, we did seep analysis, hydrometer analysis, and ultimate limit to classify soil. Then from engineering properties and soil classification, we do the slope stability analysis by using liquid equilibrium method by use slope view model. On this figure, I show the site investigation, soil boring test, and soil sample collection. From the survey data, we found the slope of the swamp is 56 degrees and is about 20 meters from the bank. We found the depth of the swamp is about 4.5 meters as shown on the picture 1 and picture 2 as shown soil layer by slope view model. Boring log at the depth of the top to 3.45 meters is soft sandy clay, and from 3.45 meters to 10.95 meters is hard steep sandy silt, and emerald is shown on boring log. Basic property of soil we classify by USCS method. From N16, we back calculate to determine CU and then geostate from Hara et al. 1974. The depth of 1.5 to 3 meters is about 40 kPa. Then it up to about 225 at 6 meters and drop to 180 kPa at 7.5 to 9 meters and 325 as maximum, and then geostate at 10.5 meters. Figure equal is 0. Result, the water level is on top the bank. We analysis slope stability by Macalester, Pins method, Bishop, Spencer, Orderly, and Janbu method. We found the safety factor is about 8.4 to 8.8. At water level 1.5 meters from the top bank, safety factor is about 4.8 to 5. At water level 2 meters, safety factor is about 4.4 to 4.6. At water level 2.5 meters, safety factor is about 4.2 to 4.4. At water level 3 meters to 4.5 meters, safety factor is about 4.2 to 4.3. The same. Conclusion. From analysis, the safety factor more than 3 safety for Bung code of swamp. In the future, we compare safety factor liquid equilibrium method and finite element method. We will determine displacement in the field from inclinometer and compare with displacement from finite element method to 5% accuracy. Thank you for your attention.
Thank you very much. Does anybody have question for him? No. You presented several tables, safety factors on several methods. Why don't you make just graphs? It will be easy to compare how the safety factor will decrease or increase according to the water level.
Sorry, sir.
You have several tables. Right? This is water level, what, -4?
Yeah, -4
The next-
on top.
The next slide. What is it?
Let's
Go to the next slide.
next slide.
4.5.
Yeah, is
Why don't you make a graph
or
that shows how the safety factor will change according to the water level? and compare.
We will take a graph when we complete analysis finite element and limit equilibrium.
Okay.
We to compare on the graph, but now we analysis is one this limit equilibrium method.
So your next step is
Next step we compare liquid and finite element method แล้วก็ and we determine displacement with geometer on the field compare with displacement on finite element method.
okay.
Which calculate and on field.
Displacement sensor.
Yes.
Using displacement sensor.
Yes.
Okay. Thank you very much.
Okay, thank you.
Okay, maybe she has one question for you. He's gone. Sorry.
You have not shown the variation in the failure surfaces and water table waves. How you assume single failure surface you arrive the factor of safety or failure surface?
What is the failure surface?
Surface you assume the
Slip surface.
slip surface.
Is it only one?
I don't
Shown here.
show on this slide, but we calculate and analyze it. But we don't take now.
Because factor of safety also depends on your slip surface.
Yes. In my understanding, he is doing just preliminary study. Then he will go deeper next time. Keep courage. Thank you very much. Thank you.
Thank you, Dr. Hamidou Tampura, for your nice cooperation. Now, lunch break. After lunch break at 1:30 p.m., session 5 will be held at room number 8 and session 6 will be held at room number 2.
Ladies and gentlemen, the lunch will be the that room, next room from there, and we want to inform you that all foods are halal.